Welcome to qnawire.
To solve this question, we begin by discovering what is the necessary acceleration to reduce the velocity of the craft to zero when it touches the surface of the moon. For that, we can use Torricelli's equation, which tells us the following. The velocity squared is given by the initial velocity squared plus 2 times the acceleration times the displacement. Let me choose my reference frame as being this vertical axis pointing upwards. Then we apply Torricelli's equation as follows. The velocity squared should be equal to 0 at the end of the landing. The initial velocity was 18. Then we have 2 times the acceleration, which we don't know, times the displacement. The displacement is minus 165 meters because the displacement is happening on the negative direction on my reference frame. So, times minus 165. Then we have to solve this equation for the acceleration, and it goes as follows. 2 times a times 165 is equals to 18 squared. Then a is 18 squared divided by 2 times 165. This results in an acceleration of approximately 0.982 meters per second squared. Notice the plus sign of the acceleration. It means that the acceleration points to this direction. And then it's correct because the velocity is downwards, so in order to reduce the velocity, the acceleration must point upwards. Now we have to calculate what is the thrust necessary to produce such acceleration. For that, we use Newton's second law, which tells us that the net force is equal to the mass times the acceleration of the craft. The net force is composed by two forces, the thrust force pointing upwards minus the weight force pointing downwards. And this is equal to the mass of the craft times its acceleration. Then the thrust force is given by the weight force plus m times a. The weight force is given by the mass of the craft times the surface gravity. Be careful because now we are at the moon, so we should use the surface gravity of the moon. Using the values that were given by the problem gives us a thrust force that is given by 1.14 times 10 to the 4 times 1.6 plus 1.14 times 10 to the 4 times 0.982. And this results in a thrust force of approximately 29,400 newtons. This is the answer for this question.